In this example, let's take a look at how a ratio can be used to solve a real-life problem. So let's use the example of modern TVs, plasma screen TVs. TVs nowadays have an aspect ratio of 16 to 9, meaning the length of a TV and its width are in a ratio of 16 to 9. This is compared to the older TVs, the blockier TVs, that are in a ratio of 4 to 3, meaning they were more close to being a square than these new televisions are. So our new plasma screen TV has a 50-inch diagonal. That's how televisions are measured, along their diagonal. And we're going to use this aspect ratio to find the length and width of our television. Okay? So even though we have a picture of the TV down there, I'm going to go ahead and just on the side here draw a rectangle. I'm going to add in the diagonal. So let's go ahead and add that in. So there's the 50-inch diagonal. And then I'm going to label the sides 16, and I'm going to label the other side 9. Well, recall if you watched the previous video that that does not mean the sides of this rectangle are 16 times 9. But to keep them in the same ratio, they're going to be multiples of 16 and 9. So I'm going to add an x to each one. If I go ahead and look at what I formed then between the two length, or the length and the width, and that diagonal, I have a right triangle formed. And so what we'll do, as we've done all along with right triangles, to find missing sides, I'm going to set up the Pythagorean Theorem. So my two legs are 9x and 16x. So I'm going to go ahead and write down 9x squared. Notice I use parentheses. I have to make sure I square both of those things. Plus 16x squared, and I'll put that equal to the hypotenuse, which in this case is the diagonal of the TV, so 50 squared. Okay? When I go ahead and multiply 9 or do 9x squared, I have to make sure I do 9x times 9x. In other words, 9 times 9 gets me 81, and x times x gets me x squared. I've got to do both parts of that. Similarly with the next piece, 16 times 16 is 256, and then x times x is x squared, and finally 50 squared gets me 2,500. Okay. From there, let's combine like terms. On the left-hand side, both of those have x squareds in them, so I can add them up and get 337x squared equal to 2,500. And again, if you ever need to pause the video to check my math or do the math yourself, please go ahead and do that. At this point, there's two things left to do. There's dividing by 337 and taking a square root. And yes, it does matter what we do next. My next step from here is going to be to divide by 337. Taking the square root should be the final step of this problem. At this point, I get a pretty nasty decimal, so I went ahead and rounded that. 2,500 divided by 337 got me about 7.42. And then to finish this, I took a square root to get rid of that squared. Again, I'm going to get a decimal, so I rounded to one decimal place. I got x equal to about 2.7. Now, with all that work, it'd be a shame to kind of stop there and forget what we were trying to do. The question wasn't to find x, the question was find the length and width of the television. Well, if you watched our previous video about the triangles, you know what to do with this x value. Now that we know what x is, let's plug that back in to both of those values to find the length and find the width of the TV. So doing 9 times 2.7 gets me a height, width or length, whatever you want to call it, of about 24.3 inches. For the vertical side. 16 times 2.7 gets me a length of the TV of about 43.2 inches. So there's my length, there's my width. If I wanted to check this, I could do that fairly easily. Let's do a squared, 24.3, plus b squared, 43.2, and that should come out close to 50 squared. It may not come up exactly because I rounded it, but it should be very close.